is also very essential to mention the unit obtained for the particular unknown physical quantity. So we'll take care of that too. Now, Ohm's law, that is the second part we have learned. That is I is equal to V upon R, where I is the current in ampere, V is measured in watts, that is voltage, and R is resistance measured in ohms. Again, with the help of this equation, we get these equations. That is V is equal to IR, that gives you voltage. If you know current and resistance, you can utilize this formula. R is equal to V upon I, that gives you resistance if you know voltage and current. Some more formula. Resistivity of materials. For that you can write R is equal to rho L upon A, or rho, that is resistivity, equals R into A upon L. If we connect resistance in series, the formula is resistance in series is equal to R1 plus R2 plus R3 and so on. For resistances in parallel, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, and whatever resistance you connect in parallel. Now, for electric power, we can utilize this formula. P is equal to V into I, or P is equal to I square into R, or P equals V square upon R. It depends upon what is given to you. You can use either of these formula. Now, we also have formula for heat energy, that is H equals I square RT, or V square upon R into T. For Ohm's law, we can use this one also. Means if we know the value of, if we want to know value of current I, then I can utilize I is equal to V upon R, or we can use P upon V or square root P upon R. Similarly, to get the value of power, I can utilize these three formula: V into I, or V square upon R, or I square into R. That is measured in watts. This is what is mentioned here. Again, if V is unknown to me, voltage, I can use either I into R, or square root P into R, or P upon I. Similarly, if I have to find out value of resistance R is in ohms, then I can utilize V square upon P, or V upon I, or P upon I square. So remembering this, you can include so many formulae together. So if you remember this particular chart, you can find out unknown power, current, voltage or resistance. Now let us take example one by one. This is the example. What charge flows through a cross-sectional area of wire in 10 minutes if the emitter measures the current of 5 milliampere? See, what we have to measure here is only the charge flowing through the wire. For that, we are given current and time. So, first of all, as we have discussed, that we will write down what is given to us, and then we will understand what formula fits in. Then we will substitute the values, and then finally we will get the answer by simplifying simple mathematical tricks. And then the unit is equally important. So these are the 4 steps we are going to follow while calculating any of the numerical or example. First step is what is given to you. That is I given to you as 5 milliampere, that is 5 into 10 raised to minus 3 ampere. This is very essential to convert all the units given to you in SI system of units. If it is in milliampere, you should change it into ampere. If it is in minute, you should change it into second. So here I have I as 5 to 10 raised to minus 3 ampere and time in 600 seconds. Now I have T, I have to find out Q. So what is the related formula? That is I is equal to Q by T. I want to find out Q. So Q is equal to I into T. I have T. Just simple mathematical calculation and the answer is in front of me. I am substituting I as 5 to 10 raised to minus 3, T as 600 and I am getting Q equals 3 coulomb. Mind well, please don't forget to write this unit of the unknown quantity asked to you. That is equally important while calculating any numerical. Let us take another example. When a 3-volt battery is connected to a light, a current of 6 milliampere is observed. What is the resistance of the light filament? Again, let us see what is given to us. That is voltage supplied 3 volt. Current is given as 6 milliampere and we want to find out resistance. Again, we need to change this 6 milliampere into ampere. So, now let us visualize this one as voltage of 3 volt or source of EMF is of 3 volt. 6 milliampere current flows through it. I want to measure what is the resistance of light filament. I have Ohm's law as R equals V upon I, that is given by 3 volt and I have converted this 6 milliampere into ampere. It is 0.006 ampere. So the result is R is equal to 500 ohm. That is the value of resistance of light filament. So what we have done? We have simply substituted all the values given to us in Ohm's law formula. So this is what you need to do when you start calculating a numerical, that you should know what is given to you and you should decide what is the formula that fits in to find out the unknown physical quantity given to you. Again, see, I have find out the amount, that is magnitude of resistance, as well as I also mentioned unit of the unknown physical quantity. So 1 ohm is equal to 1 volt upon 1 ampere. That is here. So I mentioned it as ohm. Now another example. A 6 ohm resistor has a power supply of 20 volt across it. What will happen to the resistance if the voltage doubles? See, current remains same, only voltage doubles. So what I need to do is, first of all, I is equal to V upon R. That is, V is given as 20, resistor is 6 ohm. So I have I equals 20 by 6. Now, if voltage gets doubled, means if I write 20 into 2 here, instead of 20, then I should write 6 into 2 here, because current remains same. Even if I double the voltage, current remains same. So, what happens? If I double the voltage, new resistance will get doubled. Another example that has been asked in recently in January 2016 GTU exam. The potential difference across a resistance of 14 ohm is 35 volt. Find the current through it. Again, we are given resistance, we are given volt, means potential difference. We have to find out current. Naturally, we will use Ohm's law. So I is equal to V upon R. Substituting these values of V and R in this example, I get is 35 upon 40. That gives me, after simplification, I is equal to 2.5 ampere. So this is the easiest way to calculate an example.